Vanakkam, Namaste, Namaskar, welcome back to Jal Prayag. I'm going to do a quick small topic again, which is in a sequence to the last video we have done. So that is vertical sextant angle. I had mentioned while I was doing that vertical sextant angle uses Radian principle, and use of the Radian principle can be done for two types of questions. So one was when I was using VSA. We did not see the derivation of the formula of VSA, but it uses the Radian principle. And the second method of chart work where I'm going to use this Radian principle is a very small concept called sailing around an arc. Let us see what is a catch here and what is the purpose. It's very easy to understand and very practical to use. You can use this Radian principle even in day-to-day life matters also. So let us look how we're going to use it for sailing around an arc. As I said, like VSA, sailing around an arc also involves the Radian principle. We'll just quickly have a look on that Radian principle, how it is being used. As a recap of what I had mentioned in the last video also, 1 radian is 57.3 degrees. And if you say pi radians, so it is 180 degrees because pi is 3.1416. You multiply with 57.3, you will get 180. And very similarly, if I do 2 pi radians, it is 360 degrees. Okay. So right now, what I have done is given you a relation of an angle which is radian and how much it comes to based on the pi value. But let us see what is a practical use more slightly in a modified way. I can use this 2 pi radians instead of writing 2 pi radians. I can use or write it as 2 pi radius also. That means, as I had mentioned, I'm involving a circle. If I multiply 2 into pi into the radius of that circle, you will see that angle subtended is 360 also. So let us quickly have a look on how it is. I'm drawing a circle. I have chosen a radius. It could be anything. It could be anything. Now, if I start measuring the circumference, please remember now I'm trying to measure a distance. Okay, circumference, you can see, is a circle. So let us say you walk around that circle or you run around that circle, which is the circumference. You will be able to measure a distance. So that distance is also called an arc. Why? Because it is a circular shape. Right now, if you see this, I have covered half of the circle. Okay. And I can cover the full circle also. So if I cover this full circle, the distance is called 2 pi radius. And that is equivalent to an angle subtended. That means you started from one point, came back to one point, you covered 360 degrees also. So your 2 pi r actually is the circumference of the circle which you have been using in all your simple mathematical calculations also. So what I'm trying to do is I'm trying to give a relation between the angle and the arc. Okay, arc is that circumference. Angle. So you can say that 2 pi radius is a distance. At the same time, I'm trying to relate with 360 degrees. So I'm going to use this method for me to use it, for me to calculate in your sailing around an arc. So I have just clearly given here, which means that if I run the full circle, let us say I'm running around that full circle, the distance what I cover is 2 pi r, 2 pi radius, and the angle which I subtend is 360 degrees. So that means I can use this as a ratio, and that is what I'm going to do. So let us proceed with that example, and then we can understand better. So I'm going to use this. When do I use it in chart work? Particularly, let us say my vessel is going to take a circular path, and I want to measure the distance exactly. Why? Because now it is not a straight line, it is circular. So how do I measure distance accurately? So in real life, I can use a divider also, and I can start measuring along a circular path, but that is not a very professional way, and you could have slight errors also. So if you want to be professional, it is prudent for you to use the circumference relation with the angle subtended. You will get more accurate answer. So that is more professional. Okay. So what do I do in chart work? Uh, my first job is, if I'm sailing around a circular path, I need to find the correct distance. If I use the correct distance, I can get a better judgment of my ETA. And when do I use this circular path? Usually you use it if you want to avoid any danger. Your master tells you to keep a safe distance off and then put a passage plan. So you can do it. If you honestly look into a practical aspect of a ship, please remember, whenever a vessel turns, it never takes a straight path. It always takes a circular path also. So with the correct distance, by using this Radian principle, I can find how much exactly I've done on a circular path, and I can get a better ETA, and my problems can be solved more accurately. So I'm going to take an example. Let us assume that I had two waypoints on my chart. Let us say Alpha and Bravo. And when I joined as a rhumb line or a straight line, I found out the distance was around 25 nautical miles. This is a hypothetical example. But there were some offline dangers, and there was a land, let us say. So I had a land, and for a reference, I had a lighthouse X-ray also, but there were some offline dangers. So the master tells you that please don't keep anywhere close to 5 nautical miles with reference of the lighthouse X-ray, okay? Because there are some offline dangers. So he says that keep a minimum distance of 5 nautical miles. So the most logical way of solving this kind of problem is, I'm going to draw a circle of 5 nautical miles, and that clearly tells me that I should never go into this circle. So I should not go into the circle of 5 nautical miles. Now you can see what I've done is I've cut across the rhumb line course. So what do? Is I modify my passage. I introduce two more waypoints, and I call them Charlie and Delta. You can see exactly where the circle cut the original rhumb line course. I'm calling this Charlie and Delta. So how do I use this and still stay away uh, for achieving my minimum distance, minimum clearance from that? So what do I do is, I'm going to join this lighthouse X-ray with Charlie and Delta, and then I'm going to measure this angle on the chart. I can measure this angle on the chart. Let us say it was theta. Okay. Now, finally, when I finish all my problem, what am I going to do? I'm going to sail a straight line or rhumb line course from Alpha to Charlie like this. I can sail a circular path like this from Charlie and Delta. Then again, I can go straight line from Delta to Bravo. So this is what I'm going to do, and we're going to do the simple calculation. Please remember, measuring Alpha Charlie is very easy with your divider. Measuring Delta Bravo is very easy. But as I said, Charlie and Delta, the circular path also can be measured by a divider, but it's not prudent. I can get you a better answer, more accurate answer, and that is what we are going to do. Now, here is what I'm going to do using the Radian principle. Why? Because now this total distance, that is a combination of a straight line, a circular path, and again straight line, is going to be more than 25 nautical miles. Let us find out how much exact it is. I'm going to use the Radian principle. Radian principle says that 1 radian is 57.3 degrees, and that 57.3 degrees, what it subtends is the radius of the circle. Here we already know the radius of the circle is 5 nautical miles. Why? Because that is what was a safety circle which we have drawn. I know the radius. Now assume this theta what we got from here measured is 78 degrees. So I'm going to use this relation. If theta was 57.3 degrees, which is 1 radian, the distance sailed around the arc would have been exactly 5 nautical miles. But now it is not. So let us do a quick calculation. For 78 degrees, how much will be the distance you have traveled around the arc? So I'm going to use that ratio, 57.3. For 57.3 degrees, it is 5 nautical miles. For 78, how much? It comes as 6.8 nautical miles. Now, what is the exact distance what you have done? I have calculated alpha Charlie, let us say whatever you get, then plus 6.8 plus delta Bravo, and now I can give you a better ETA. So now I've got the exact value of how much you have sailed around an arc. So what the vessel is going to do practically here is, your vessel can sail like this. The moment it reaches Charlie, it is going to start a circular path. And you can see when I'm exactly tangent there, this is going to be 90 degrees. That means that lighthouse is going to be a beam on my port side. And then I'll carry on like this. The moment I reach, again, I'm going to go back to 090 and I will continue. So this is what is sailing around an arc, a very simple principle, not too much of wavering around or waggering around, whatever you want to call it. So you can use this, as I said, it is not only used in chart work. The Radian principle can be used in a lot of simple things in day-to-day life also when you are trying to measure using a circle. I hope the small concept was good enough. You might get it, you may not get it also as a part of chart work question. But anyway, this Radian principle can always be of help for you in many practical parts of your life. Doesn't matter if it is chart work or not. That's it for now. Keep watching Jal Prayag, and I'll catch you up with the next video regarding chart work soon. And until then, Vanakkam, Namaste, Namaskar.